Comparing empirical and molecular formulas. In this video, I'll be talking about what empirical and molecular formulas are. I'll be talking about what the point of an empirical formula is, and I'll be teaching you how to convert between the two. So this is the structure of a molecule called 2-butene, and I want to figure out both the molecular formula and the empirical formula for this molecule. So the molecular formula is going to tell us what elements are present and how many atoms of each element are in this molecule. So we are going to write a capital C, which is the symbol for carbon, and we need to count how many carbon atoms we have. 1, 2, 3, 4. We have 4 carbon atoms, so I'm going to write a subscript 4. Same for hydrogen. We need a capital H, the symbol for hydrogen. I need to count how many hydrogen atoms I have. 1, 2, 3, 4, 5, 6, 7, 8. So I need a subscript 8. So my molecular formula for 2-butene is C4H8. Empirical formula is different. An empirical formula still tells us which elements are present, but they're going to be in their lowest whole number ratio. So imagine you had a fraction of 4/8. And you are in a math class and you needed to reduce this fraction. To reduce the fraction, you'd need to recognize that these are both evenly divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. We can reduce this fraction to 1/2. My empirical formula is going to have 1 carbon and 2 hydrogens. I'm going to write CH2. In either a molecular or empirical formula, if you only have 1 atom of a given element, you do not bother to write the number. So I'm not writing C1H2, I'm just writing CH2. Now, looking at this right now, you might not understand what the purpose of an empirical formula is. It gives us less information than a molecular formula. Molecular formula tells us exact number of atoms of each element in this molecule. This just gives us a whole number ratio. The point of this is that if you do not know what your molecule is and you're trying to figure that out, calculating the empirical formula is something that you can figure out with less information than molecular formula. So this is going to be a stepping stone. If your goal is to figure out the molecular formula of an unknown compound, you're first going to be figuring out an empirical formula. The definition of molecular formula is it's a formula that tells us how many atoms of each element are in a compound. So in the case of our 2-butene, we write a capital C, the symbol for carbon, and a subscript 4 because we have 4 carbon atoms, and a capital H, symbol for hydrogen, a subscript 8 because we had 8 hydrogen atoms. The definition of empirical formula is it's a formula that tells us the lowest whole number ratio of atoms in a compound. So for the same molecule, 2-butene, the empirical formula is CH2. This is another example. So here I've drawn a different molecule. Let's figure out its molecular formula. So first let's count how many carbon atoms are in the molecule. 1, 2, 3, 4, 5. So I'm going to write capital C for carbon with a subscript 5. And let's count our hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens. So H8. C5H8. Now, let's figure out the empirical formula. So if you had a fraction, 5/8, and you wanted to reduce it, you wouldn't be able to do anything to it. This is already a reduced fraction, which means that in this case, the molecular and empirical formulas are going to be the same. Empirical formula is also going to be C5H8. So here I have 3 example problems. I have 3 molecular formulas written, and I want us to figure out the empirical formulas. So for our first problem, P4O10. So P is phosphorus, O is oxygen. But if you had the fraction 4 over 10, and you wanted to reduce it. 4 and 10 can both be divided by 2. I'm going to divide both numbers by 2. So my empirical formula is going to be P2O5. It is valid to divide every single one of these subscripts by the same number. You want your empirical formula to have the lowest whole number ratio. Okay, second problem, C6H12O6. So you're looking at 6, 12, and 6. All three of these numbers can be divided by 6. So I would write the empirical formula of CH2O. 6 divided by 6 is 1. We don't bother to write the 1. 12 divided by 6 is 2, so 2 hydrogens. And for oxygen, 6 divided by 6 is 1. Once again, we don't bother to write the 1. And third problem, CO2, carbon dioxide. This is a case, once again, where our molecular and empirical formulas are going to be the same. 1 carbon versus 2 oxygens. If you add a fraction of 1 over 2, it is already reduced. So my answer is CO2. Look at these two molecular formulas that I have written. CH2O, this is the molecular formula for formaldehyde, and C6H12O6, this is a molecular formula for glucose. These are two vastly different chemical compounds, but they have the same empirical formula, CH2O. In other words, it is possible for different compounds to have the same empirical formula. In the next video, we are going to be calculating empirical formulas, and we can do this either by knowing the percent composition of the compound or by knowing the mass of each element in a compound. In the video after that, we are going to be calculating molecular formulas. You can calculate a molecular formula from the empirical formula and molar mass of the compound. Thanks for watching. If you feel that I've earned it, I ask that you like this video and subscribe to my channel.